The independent sample t-test is used to find out whether a difference exists between the means of two independent groups on a continuous variable. More precisely, this test lets us determine if the difference between the means is statistically significant. For example, if we want to find out whether there is a difference between male and female employees with respect to the average salary, we can use the independent samples t-test. The hypothesis of this test can be written as follows. The null hypothesis. There is no difference between the means of the two groups in the total population. And the alternative hypothesis. There is a significant difference between the means of the two groups in the total population. If the p-value of the test is lower than 5%, we will reject the null hypothesis. The assumptions we must check before running an independent sample t-test are the following. The independent variable is categorical, either nominal or ordinal. If this variable has 3 or more categories, we must decide before running the test which categories we want to compare, because the t-test only compares 2 categories. The dependent variable is continuous. There is independence of observations. In other words, there is no connection between the observations or measurements in the two groups. Each sample unit must belong to one group and only one, and the units in the two groups should be totally unrelated. Moreover, the members of the first group cannot influence the members of the second group, and vice versa. Assumption number 4. The dependent variable is normally distributed in both groups. The dependent variable has no significant outliers in either group, and the variances of the dependent variable in the two groups are equal. In other words, we have homogeneity of variances. If the two groups have the same size, we are talking about a balanced design. If not, our research design is not balanced. Ideally, we should create a balanced design because this way the t-test is more resistant to the violation of the assumptions. But oftentimes this is hard to do in practice. Okay, let's move to our example now. Let's suppose we want to measure how effective is a Spanish course for the employees in multinational companies. To that effect, we built a sample of 268 employees who speak Spanish at different levels. 110 of them have taken the Spanish course. All these employees go through a test of Spanish and get a score from 1 to 100. The higher the score, the better they know Spanish. We want to determine whether there is a significant difference between the two groups with respect to the average score. Here's our database. Of course, the data are fictitious. This variable, course, shows us if the employee took the Spanish course or not. Let's see how it's coded. So 1 means did not take the course and 2 took the course. This will be the two groups to compare. We want to know whether people in this group who took the course speak Spanish better on average than the people in this first group did not take the course. And this variable, score, is a numeric variable that stores the scores got by the employees at the Spanish test. So the question is there a difference between the average scores in these two groups? Now, before running the t-test, we must check the assumptions 3, 4, and 5 here. That's what we will do in the following lesson.